So here's your third and final set of notes about how elements make bonds to create compounds. We had 2 other videos about ionic bonds, and this one will talk about the other type of bond that you need to understand, which involves sharing of electrons, and it's called covalent. A way to remember what covalent means is just to break down the word. And if you have ever played on a sports team and there have been co-captains on your team, those people typically share the responsibility of being the captains. So if you see the prefix co, that means to share. And then the rest of the word looks like the word valence electrons, which is talking about the outside ring of electrons that it's involved in bonding. So those are the easiest ways that I can think of to help you remember what this means. So a few of the properties and characteristics about covalent bonding involve that it is formed between 2 or more nonmetals. So these are elements that are located to the right side of the periodic table. And these 2 or more atoms share electrons. This is also known as molecular bonding. Valence electrons are shared, so when you count them in the ring around that final orbital, you would actually count the shared pair for each of the elements. And I'll kind of point that out in a picture couple slides from now. So we talked about properties of ionic bonds, and now we can compare those same properties to covalent bonds. In terms of their melting and boiling points, it's lower for covalent bonds, which means it takes less energy to get them to change phase. Because we're dealing with nonmetals in these bonds, they're not good conductors. And among all the molecules that make up the larger substance that we can see, they have weaker bonds. So there are 2 types of covalent bonding. The first type is called polar. Polar is a covalent bond in which electrons are shared unequally, so it creates a positive end and a negative end, or poles. So for example, water is a type of polar covalent bond. So with polarity, electrons are pulled closer to the more negative atom, that's where all the negative charge is, and then we end up leaving a slightly positive end because the nucleus is pretty much left out in the open. So if you notice here, all the electrons in this bond are surrounding the oxygen. And so if we counted the electrons in this ring, we would count all of the ones in the ring, even if they are shared. So oxygen has a full outer shell of electrons, and hydrogen only has these 2 electrons right over here. So because the nucleus is positive, since it's exposed on either end, that's why we end up having a slight positive charge. A nonpolar covalent bond is where the electrons are shared equally. They're not pulled in one direction, and they're actually spread out all around the molecule. And there are actually 6 elements that we talked about before where they come in twos or in pairs in nature. And they have nonpolar covalent bonds, so they evenly distribute their electrons between them. And so those diatomic molecules you need to know are listed here. You've got nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And when we're in class, I'll teach you a method of remembering exactly where they are in the periodic table. Finally, now that we've talked about the different types of bonding, and we've done some practice making bonds in class, hopefully you're starting to notice that there is a pattern. And the fact is that all the groups tend to arrange themselves the same way with their valence electrons. And because of that, they bond the same way. So this is another thing we can add to the list of ways the families have similar characteristics. So group 1 elements, so alkali metals, tend to lose 1 valence electron, which means they'll have a +1 charge if they were to become an ion. Group 2, the alkaline earth metals, lose 2 valence electrons, giving them a +2 charge. Group 13, starting with boron and working its way down, those guys are going to lose 3 valence electrons, so they'll have a +3 charge. Group 14 is interesting because it has the zigzag line going through it, and it ends up having a nonmetal, metalloid, and metals. And so we can't really say all of them do the same thing. The nonmetal and metalloids will typically share 4 valence electrons, so they'll be involved in covalent bonds. And the metals, tin and lead, are going to act like everything else to the left of the zigzag line, where they lose valence electrons, so they would have a +4 charge. Group 15 is getting closer to the noble gases on the right, and so they would prefer gaining 3 valence electrons, and that would give them a -3 charge. Group 16 would gain 2 valence electrons, and this one starts with oxygen, and they would have a -2 charge because they bring 2 extra negatives in. And finally, group 17, the halogens, gain 1 valence electron, so they'd have a -1 charge. And remember, we don't include group 18 on this list because they do not make bonds with other elements. They like to stay by themselves because they have all of the valence electrons that they need. Some exceptions here include hydrogen. Hydrogen is in group 1, but if it were to lose its only electron, it would have nothing left, and it doesn't want to do that. So instead, it would share its 1 valence electron in order to fill up its own shell of just 2. And finally, the diatomic molecules that we just mentioned on the slide before are also involved in covalent bonds, so they share valence electrons. So when we're back in class, we're going to have some more practice making bonds, both with ionic and getting some understanding of how ionic and covalent bonds are different. And again, just like always, if you have any questions about any of the slides that you've just taken notes on, please write them down, and that way we can discuss them in class when we come back. Hope you have a great day off, and I'll see you later.